Determine the equation of the least squares regression line for the data. Let's take a look at what's happening here. So truck drivers travel a certain distance and have a rest before traveling further. Okay, makes sense. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes, and the amount he rested in minutes before he continued his journey. The information is given in the table below. We have the distance traveled in kilometers, which is our x, and the amount of rest time in minutes, which is our y. It's really helpful that they're telling us which one is the x and which one is the y. Okay, sort of makes our equation simple. 1.1, we're supposed to determine the equation of the least squares regression line for the data. Well, our equation for this is y is equals to a plus bx. Basically, we need to find a and b. If we do that, we have the equation for the least squares regression line for the data. I've showed you how to do this before, but let's go ahead and do it again. We're going to use our calculator. So what you want to do, you want to press mode setup, and then you press stat, which is option 3 on this calculator that I'm using. After that, you press 2, as you can see that it says a plus bx, which is what we are interested in. Okay, when you do that, you're going to have this table. You enter your x variables and you enter your y. Okay, so let's go ahead and punch in the x. We have 180 followed by 200, 400, 600, 170, 350, 270, and 300. Okay, after doing that, we want to punch in the y values next to the corresponding x value. So 180 is going with 20, 200 is going with 25, 400 is going with 55, 400 with 55, 600 with 120, a big jump between 400 and 600, and then 170 is going with 15, 350 with 50, 270 with 40, and lastly 300 with 45. You have to verify that you've entered the correct data, because if you make a mistake when you enter your data, all your answers are going to be incorrect. So after entering your data, you press equals to a couple of times, you press AC. After doing that, we have shift 1, and then we go to 5, regression. It can be option 6 on a different calculator, it doesn't matter, but we want regression. Okay, and then let's go ahead and determine A. A will be equals to, so we have A being equals to. So let me press 1 and equals to. If I do that, I get minus 23.85 as the value of A. Okay, now I'm interested in the value of B. So I'm going to press AC, shift 1, 5 for regression, and then now I press 2 for B. B is equals to 0.23 if I round it off to 2 decimal places. So there we go. We have the equation for the least squares regression line using our calculator. So we're going to have y being equals to minus 23.85 plus b, which is 0.23 multiplied by x. So that is our equation for the least squares regression line. Let's move forward and do 1.2. So 1.2, if a truck driver traveled 550 kilometers, predict the amount of time in minutes that they predict the amount of time in minutes that he should rest before continuing his journey. So we are given an x, which is equals to 550, and we want the y, which is the amount of time. So we are substituting 550 into this equation. If we do that, we're going to have minus 23.85 plus 0.23 multiplied by 550. I need to put that in my calculator. So minus 23.85 plus 0.23 multiplied by 550. I'm getting 102.65. Let me see if it makes sense. 400 is 55. 600 is 120. So 550 should be in between. Yeah, I'm quite happy with that answer. It makes a bit of sense, right? If it was 10 or if it was 300, then it wouldn't make any sense. Anyway, stories. Let's carry on. Let's do 1.3. Write down the correlation coefficient for the data. Again, in order to do this, we have to use our calculator. So let's go ahead and do that. AC, shift 1, 5 for regression, and then we press 3 for R, the correlation, right? We get R is equals to, let's see, R is equals to 0.98. So, right, that is the correlation coefficient for the data. 1.4. Interpret your answer to question 1.3. Well, the phrasing of your answer will be different from probably other people. But basically, there's a strong correlation between the distance traveled and the amount of rest time. As you can clearly see, it is 0.98. If it was 0.2, 0.1, then there will be a very weak correlation between the X and the Y. But in our case, we have a very strong correlation. So the phrasing of that answer will be different, right? But basically, there's a strong correlation between the distance traveled and the amount of rest time in minutes. That is 1.4. On the other hand, 1.5, at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. Okay, we have the amounts. And the first question, 1.5.1, calculate the mean amount of money he spent at each stop. Again, we can use our calculator here. Let me show you how. So we press AC. Now we want to change our data. So we're going to press mode setup, and then we press 3 for test. And now we press 1 for one variable. We are only interested on one variable now. So we're going to have 100, 150, 130, 250, 180, 200, 190. Okay, and then we press AC. We want the mean. So for the mean, we're going to press shift 1. Now we don't press 5, but we press 4 instead. So let's go ahead and do that. Okay, so the mean is X bar. That is option 2 on my calculator. When I press that, I'm getting 150. So that is my mean, 150. Okay, you can do this with your calculator, or you can do this manually. I think answer only will be the full marks. If you write only the answer, you still get the full marks. I think that's how it works. Okay, you can say otherwise if that is not the case in the comments. And 1.5.2, calculate the standard deviation for the data. So shift 1, 4, obviously, and then we press 3. That is the sign for standard deviation. So the standard deviation is, our standard deviation is 50.497, so 50.5. That's our standard deviation. And the question that follows, 1.5.3, we want to know how many stops did the driver spend an amount that was less than 1 standard deviation below the mean. What does that mean? 1 standard deviation below the mean. So is the mean minus the standard deviation, which is 50.5. Okay. What do I get? I get 99.5. 1 standard deviation below the mean. Okay. So anything less than 99.5. I think it is only 50, which is 1 standard deviation below the mean. So at how many stops? At 1 stop, at only 1 stop. Okay, that's where the amount spent was 1 standard deviation below the mean. Before I let you go, which question should I do next? Please leave a comment. Let me know which question you want me to do next. The answer to 2.4, the value of k. K is equals to 12. And I will show you why that is the case. Let's do 2.1, 2.2, and 2.3 first. Okay, so 2.1. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. Okay, all teachers present on a specific day were interviewed. the information is shown on the table below. Okay, and the first question, 2.1, complete the cumulative frequency column provided in the table in the answer book. Well, I don't have the answer book, so I'm just gonna put the cumulative table right here. So let me go ahead and do that. So on the first column, I'm just going to have 5. And then following 5, I'm gonna have 5 plus 15, which is 20, okay? After that, I'm gonna have 20 plus 13, which is 33, okay? 33 plus 5 is 38. 38 plus 2 is 40. So your table for the cumulative frequency should look something like this: 5, 20, 33, 38, and lastly 40. Okay, so that is 2.1. We are done with that. 2.2, on the other hand, how many staff members were interviewed? The staff members that were interviewed, 40. Okay, that is the total number of staff members when we add all these up: 5 plus 15, 20 plus 13, 33, plus 5 plus 2, 40. So we are 40 staff members at this school. That is 2.2. Okay, 2.3. How many staff members drank fewer than 6 glasses of water during a school day? So let's take a look at how our data is represented. So in this line, we have fewer than 6, right? As this is less than 6 and not less or equals to. So the people who drank fewer than 6 is 13 plus 15 plus 5. Those are the people that drank fewer than 6 glasses of water in a day. So 15 plus 13, 13 minus 2 is 28, okay? 28 plus 5, so we have 33. 33 people drank less than 6 glasses of water, which makes sense. Why are you drinking 6 glasses of water anyway? But that's not what we're interested in. Let's go ahead and do 2.4. The question we are really interested in, okay? This took me some time to figure out, but let me show you why I'm saying that k is equals to 12. K is equals to 12. If you didn't get 12, your answer is wrong. There is no way. I answered this question using a lot of different methods, and the answer, k is equals to 12. There's no way around it. Okay, so the staff committee observed that k teachers were absent on the day of the interviews. Okay, it was found that half of these k teachers drank from 0 to fewer than 2. Okay, so let's make sense of that information from the get-go. Let's look at the column with the number of staff members. I want to show you something. Okay, so k teachers were absent, and then half of these k teachers drank between 0 and 2 glasses. So for 0 to 2 glasses of water, we have 5 plus k divided by 2, okay? Because we know that k divided by 2 teachers drink between 0 to 2 glasses of water. Let's carry on reading our information. While the remainder of them drank from 4 to fewer than 6. So 4 to fewer than 6, we have another k divided by 2, okay? We have k teachers that were absent. Half of them drank between 0 and 2. Half of k is k divided by 2. And the remaining, which will be k divided by 2, drank between 4 to 6. So, yeah, the number of staff members for 4 to 6 is 13 plus k divided by 2. That is the important part. You need to be able to comprehend that in order to answer this question. Okay, let's carry on and hear the stories. When these k teachers are included in the data, the estimated mean is 4 glasses of water per staff member per day. How many teachers were absent on the day of the interviews? Basically, what is the value of k? Okay, so let's go ahead and compute that. The formula we have the mean being equals to the sum of the midpoint multiplied by the frequency divided by the cumulative frequency, the total number of staff members. Okay, so we need to find the mid, and we need to multiply that mid with the frequency and then divide by the cumulative. Let me show you what I'm talking about. Okay, so let's find the midpoint. So the first step is to find the midpoint. What is the midpoint of 0 to 2? That is 1. The midpoint of 2 to 4 is 3. That of 4 to 6 is 5. Of 6 to 8 is 7. Of 8 to 10 is 9. So that is the midpoint. And then we have the frequency, okay? So the frequency for 0 to 2, we know that it is 5 plus k divided by 2, followed by 15, and then 13 plus k divided by 2. For 7, the frequency is 5. For a midpoint of 9 glasses, the frequency is 2, okay? And then now we're supposed to have the midpoint multiplied by the frequency. So what is 1 multiplied by 5 plus k divided by 2? That will just give us 5 plus k divided by 2. Okay, 3 multiplied by 15, that's 45. And then what is 13 multiplied by 5? Let me just put that in my calculator real quick. So I have 65. I have 65 plus k divided by 2 multiplied by 5. So I have 5k divided by 2. 7 multiplied by 5 is 35. And then 9 multiplied by 2 obviously is 18. Okay. And then the total. Okay, I have to find my totals now. The total for the frequency, I know that the cumulative frequency was 40, right? So now I'm going to have 40 plus k, right? For the k teachers that were absent. Okay, that is quite easy to see. And then midpoint multiplied by frequency, I need the total for that. I'm going to add up the numbers first. So I have 5 plus 45 plus 65 plus 35 plus 18, which is 168. I have 168 plus 1 divided by 2k plus 5 divided by 2k. That is plus 3k. Okay, now we can go ahead and substitute on our formula. Let's not forget that we're supposed to come and substitute here. If we do that, we're going to have the mean, which is 4, being equals to the midpoint multiplied by the frequency, the sum. So that is 168 plus 3k divided by the cumulative frequency, that is 40 plus k. If we cross multiply, 4 multiplied by 4 is 16, so this will be 160 plus 4k, which is equals to 168 plus 3k, okay? If I take 3k to the left-hand side, I'm going to have 4k minus 30k, which will be k. 168 minus 160 should be 8. Well, it seems like k is actually equals to 8 and not 12, okay? Which question do you want me to do next? Let me know in the comment section. Which question do you want me to do next? Okay, let's chop it up real quick. So the first question, 3.1, we want to calculate the length of SL and leave our answer in set form. Okay, let's go ahead and do that. So SL will be equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. The basics, really, nothing complicated. I don't think we should be getting these kind of questions wrong. So we have SL. Let's take L as our first point and S as our second point. So y2 will be the y value of S, which happens to be 5, minus the y value of L, which is 1. So we have 5 minus 1 squared plus x value of S, that is 4, minus the x value of L, which is minus 4. So 4 minus 4 is plus. So we have plus 4 squared, okay? The answer here is 4 square root of 5, okay? We shouldn't be getting that wrong. We shouldn't be getting that wrong. Let's go ahead and do 3.2. 3.2, we're looking for the gradient of Sn, okay? So this is S and this is N. We have said that S is our second point, so let's take N as our first point and see what we get. So the gradient that is y2 minus y1 divided by x2 minus x1, right? The y value of S is 5 minus the y value of N, which is minus 3. So 5 minus 3, that is just plus 3, okay? Divided by the x value of S, which is 4, minus 2, so that is 4 plus 2. So we have 8 divided by 6, which should be 4 divided by 3, okay? I think that is the answer we are supposed to get. I don't know if I trust that answer or not, so let me do it the other way around and see if I get to the same conclusion. So minus 3 minus 5 divided by minus 2 minus 4 minus 8 divided by minus 6. Okay, I think we're good to go. That is 3.2. We are really sticking to the basics. We haven't solved any question that is complicated up to so far, so we should have those marks in the bag. 3.3, calculate the size of theta, the angle of inclination of Sn. Okay, we know fully well that tan of theta should be equals to the gradient of that line. So theta will be equals to tan inverse of the gradient, which happens to be 4 divided by 3. Okay, let me just put that in my calculator again so that I don't make any silly mistake. That is 53.13 degrees. Okay, so how many marks? 6. So we have 6 marks in the bag. We haven't done anything complicated. It's just standard procedure. Let's take a look at 3.4. 3.4, we're interested on the size of angle LNS. Let's go ahead and denote that we have this angle LNS. Okay, how can we possibly find that angle? Well, in the question above, I was calculating theta. So let me see if I can use theta to get to angle alpha, of which is LNS in our case, okay? So because of vertical opposite angle, this angle right here should be equals to theta, okay? So this angle is 53.13. Okay, so how do I move after being able to realize that? I can find the inclination of Ln. Look at the inclination of Ln, this angle here, right? The inclination of Ln, let's call it this symbol. The inclination of Ln should be equals to theta plus alpha, okay? Why do I say that? This is an exterior angle of triangle KON. Well, not KON, but this point here. I don't know. This point doesn't have a name, but that is the point we're interested in. So that angle should be equals to theta plus alpha. So let's go ahead and find the inclination of Ln. So we have to find the gradient of Ln first if we want to find the inclination of Ln. In finding the gradient of Ln, we're going to have y2 minus y1 divided by x2 minus x1. Okay, let's take L as our second point and N as our first point. So y is 1 minus y of n, which is minus 3, okay, divided by x, which is minus 4, minus x of n, which is minus 2. So 1 minus 3, that is 4, minus 4 minus 2, that is minus 2. So the gradient of Ln is minus 2, okay? So now I have to go ahead and find angle, the inclination of Ln, okay? So the inclination of Ln will be equals to tan inverse the gradient of Ln, which is minus 2. If the gradient is negative, you're going to find a negative angle. And when that is the case, we have to add 180 degrees, okay? So let me just put that in my calculator and see what I have. So tan inverse of minus 2 is minus 63.43. I add 180, I get 116.53. 7. Okay, so the size of this angle is 116.57. What does that tell us? Let's not forget what we are proposing. That tells us that 116.57 is equals to theta, which is 53.13 plus alpha. Okay, so our angle alpha, or LKN, LNS, not LKN. I'm sorry for that. Our angle alpha will be 116.57 minus 53.13. Okay, so let me just go ahead and put that in my calculator real quick and see what I get. I get 63.44 degrees. So yeah, that is the size of angle LNS. Why am I saying LKN? LNS. Okay, let's see the gradient of ln, and then I find the angle of inclination 116. I'm looking for the angle of LNS. Okay, yeah, we are good to go. That is the size of LNS. Yeah, let me know in the comment if you found a different answer. You'll probably not find a different answer, but use a different method. I'm quite convinced that the approach I'm taking is the right one. That is 3.4. 3.5. Determine the equation of the line which passes through L and is parallel to SN. So the line is passing through L. Let me just erase all this for the sake of clarity. Okay, the line is passing through L and it is parallel SN. Do I have the gradient of SN? Yes, I calculated the gradient of SN in 3.2. So let me just go ahead and take a look. It was 4 divided by 3. So that tells me that the line of which I'm interested in will have a gradient of 4 divided by 3 x plus c. Okay, parallel lines have the same gradient. Okay, so now I just have to find the value of c, but I'm given the point L. They say that the line goes through the point L. So I have coordinates -4 and 1, which I can substitute into this equation to find c. If I go ahead and do that, the y value is 1, the x value is -4 plus c. So c is equals to 1 plus 4 divided by 3 multiplied by 4. Okay, let me just check which answer I am getting. I have 19 divided by 3. Does it make sense? 4 multiplied by 4, 16 plus 3, 19 divided by 3. Okay, I think we're good to go. So y is equals to 4 divided by 3 x plus c. Why am I saying c? X plus 19 divided by 3. C is 19 divided by 3. If I substitute -4, will I get 1? If I substitute -4, that is the equation. Let me see if that will be the case. If that will be the case, -4 plus 19 divided by 3, 1. Okay, I'm getting 1 when I substitute -4. So I'm quite convinced that I have the correct equation. Okay, you can still get the corresponding y value and your equation be wrong. That is very possible. But anyway, let's carry on. Stories. I just did 3.5, so now we have to go to 3.6. 3.6. We want to find the area of LSN. The area of LSN. Okay, let me see how I can do that. The area of triangle LSN. So we have LSN. I calculated the length of SL in 3.1. So I have SL. SL is equals to 4 square root of 5. So this is 4 square root of 5. Okay. Here I have an angle of 90 degrees. So if I find the length of LN, I can easily find the area of triangle LSN because I'll just use half base multiplied by height. Okay. So let me go ahead and use that idea. So SL, I've already calculated it above. We have 4 square root of 5. Now I just need to calculate the length of line LN. So LN will be the square root of x2 minus x1. So if I take S as our LN, not LS, okay. If I take L as our second point and N as our first point, I'm going to have minus 4 minus minus 2, so minus 4 plus 2 squared, plus 1 minus minus 3, so 1 plus 3 squared. Okay, let me put that in my calculator again, just to make sure that I'm not making any silly mistake. Yeah, I always hate it when the concept is right and I just make a silly mistake. Okay, so I have ln. This is 2 square root of 5. And the sandwich, these two lines, the sandwich an angle of 90 degrees. So I can just say that the area of triangle, what are they calling it? LSN is equals to half SL multiplied by LN sine of 90 degrees. Sine of 90 degrees. Sine of 90 degrees is 1. That is why when the angle is 90, we just say half breadth multiplied by height. Anyway, stories. This will be equals to half. SL is 4 square root of 5 multiplied by 2 square root of 5 sine of 90, which is 1. So I just need to put that in my calculator. So half multiplied by 4 square root of 5 multiplied by 2 square root of 5 multiplied by sine of 90. I know sine of 90 is 1, so let me just leave that. Okay, I'm getting 20. Do we have a unit? I don't think we're given any units, so I'm just going to say 20 units squared. Some people will say 20 square units. I think, yeah, that should also be fine. So that is the area of LSN, okay? You could have used a different method, maybe use LN and LS. Yeah, I think you should still get to quite a good answer. Yeah, you should get to the correct answer either way. And then 3.7, calculate the coordinates of P, which is equidistant from L, S, and N. I must say, I spent more time on this question than any other, okay? Right, yeah, because it is not a concept that is usually examined, okay? So you want to find the coordinates of P, which is equidistant from L, S, and N. So what does that mean? That means that LP should be equals to NP, it should be equals to SP. This is what it means, okay? So in order to find the coordinates of that point P, which will make this requirement to be true, we need the point P to be the midpoint of NS, okay? That is when we have a right-angled triangle. The midpoint of the hypotenuse will be equidistant from the 3 other points. What the question is really testing here is this concept. Do you know this concept or not? It is not difficult to compute. It is not that demanding when it comes to the algebra side of it, okay? So the midpoint, the x value of the midpoint of our hypotenuse will be x of s plus x of n divided by 2. So we're going to have 4 plus minus 2 divided by 2. 4 plus minus 2, that is 2. 2 divided by 2 is 1. And then the midpoint will be y of s plus y of n divided by 2, okay? So what is y of s? We have 5 minus 3 divided by 2. 2 divided by 2 is 1. So the coordinates of P that will make this requirement to be true, such that LP is equals to NP is equals to SP is 1 and 1. Okay, if you go ahead and calculate LP, NP, and SP, you will indeed find that they're equal when P has coordinates 1 and 1. That is 3.7. On the other end, 3.8, calculate the size of LPS. I'm going to leave that one for you. Please let me know in the comment. What answer did you get for 3.7? Okay, and also one last thing, which question do you want me to do next? Let me know in the comments. I'm always reading the comment section, waiting for you guys to tell me which question I should do next. 4.6. The smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. Okay, so we have two possible values of k. Question 4.6 is not for the faint-hearted ones. I hope I don't turn out to be faint-hearted. So let's just go ahead and give this question a try. Okay, let's start with 4.1 and hear the stories. So given that D with coordinates P and minus 2 lies on the smaller circle, show that P is equals to 4. Okay, we're given the equation of the smaller circle. We have x squared plus y squared is equals to 20. So the value of x at point D is P. So if we substitute that, we're going to have P squared plus the value of y squared, which is minus 2. So minus 2 squared is equals to 20. P squared plus 4 is equals to 20. P squared is equals to 16. So P is equals to 4. Okay, P can be equals to 4 or minus 4. But as we can see, the x value of D should be positive. So that's why we're saying that P is equals to plus 4 and not minus 4. No trickery there whatsoever, just basic stuff. Let's take a look at 4.2. So 4.2, we are told that E with coordinates, let's take a look, coordinates 6 and 2. Okay, is the midpoint of DF. Determine the coordinates of F. So we have the coordinates of D, 4 and minus 2. The coordinates of E, and we are looking for the coordinates of F. E is the midpoint of DF. So x of E is equals to x of D plus x of F, everything divided by 2. X of E, that is 6. X of D is 4 plus x of F, everything divided by 2. If we cross multiply here, we get 4 plus x being equals to 12. So x is equals to 8. The x coordinate of F is 8, which makes sense. Even if we just use translation, it should be easy to see that the x coordinate of F should be F. Okay, and then the y coordinate of F should be equals to 6. Let me show you why. So the y coordinate of F is equals to, not of F, but of E. We are using E as a bait to find that of F, right? So the y coordinate of E is equals to the y coordinate of F plus the y coordinate of D, everything divided by 2. That of E is 2, that of F we're interested in, and that of D is minus 2, everything divided by 2. 2 multiplied by 2 is 4, so we have y of F minus 2 being equals to 4. Y of F is indeed equals to 6. So the coordinates of F, we have 8 and 6. Okay, we're not experiencing any difficulty up to so far. We are moving at the speed of light. Okay, let's do 4.3. So 4.3, determine the equation of the common tangent DF in the form y is equals to mx plus c. So y is equals to mx plus c. We want the equation of df. It's a straight line. We just need the gradient, substitute 1 point, and we are done. So let's find the gradient of fe. As all the coordinates are positive, they're easier to navigate. So y2 minus y1 divided by x2 minus x1, okay? So y2, the y coordinate of f, that is 6, minus the y coordinate of e, which is 2, divided by the x coordinate of f, 8, minus that of e, 6. 6 minus 2, that is 4. 8 minus 6 is 2. 4 divided by 2 is 2. So we have y being equals to 2x plus c. Let's substitute our point E. So if we sub E of coordinates 6 and 2, we're trying to find the value of C, okay? The coordinate of E, it gives us x value and its corresponding y value. So we're going to have 2 being equals to 2 multiplied by 6 plus C. It is easy to see that C is equals to 2 minus 12, which is equals to minus 10. So we have y is equals to 2x minus 10. Okay, it makes sense because when x is 0, y is equals to minus 10. And if you look at this line, that makes sense that the y-intercept x is equals to 0 can be minus 10. Okay, that is 4.3. Let's do 4.1. Let's hear the stories. Not 4.1, but 4.4. What am I saying? So in 4.4, we want to calculate the value of t and show all working. Okay, the value of t. Right, I see the idea we're supposed to use here. So df is a tangent to the smaller and the larger circle. That tells us that m of tangent multiplied by m of the radius. Gf is the radius, as you can see. M of gf should be equals to minus 1, okay? The gradient of the tangent is 2, like we calculated above. So we have 2 multiplied by the gradient of gf, which is equals to minus 1. So the gradient of gf is equals to minus a half, okay? How can we use that to find the coordinates of t? If we use gf to find that gradient of minus a half, the only unknown variable will be t. Let me show you what I'm talking about. So we can say that the gradient of gf is equals to y2 minus y1 divided by x2 minus x1. So we have minus 1 divided by 2 being equals to y2. Let's take f as our second point and g as our first point. If we do that, we're gonna have y2, so f as our second point, that's gonna be 6 minus y1, which is y of g, 0, divided by x2, 8 minus t, okay? Let's go ahead and cross multiply. I'm taking minus 1 divided by 2 as one number, so that is how I'm cross multiplying. When I do that, I'm gonna have 6 being equals to minus 4 plus a half t. If I take minus 4 to the other side, a half t is equals to 10. So t is equals to 20. Okay, so there we go. We have the value of t. That is 4.4. 4.5. We are moving at the speed of light. We're really close to doing 4.6. Let's do 4.5 first. Determine the equation of the larger circle in the form ax squared plus by squared plus cx plus dy plus e is equals to 0. Okay, let's take a look at the information we have. We have g, which is the center, right? Coordinates t and 0. We know that t is 20, and then we have the y coordinate, which is 0. What else do we have? We need the center and the radius at least to talk about the equation of a circle. So let's go ahead and see how we can conjure up the radius. So the radius, well, the radius squared, okay? Let's find the radius first, and then we're going to find the radius squared, okay? So this is going to be the square root of the distance formula. GF is the radius. So if we find the length of GF, then we have the radius, okay? So this is y2 minus y1 squared plus x2 minus x1 squared. So the radius is gonna be equals to, I'm taking f as the second point, so y is 6 minus 0 squared plus 8 minus 20 squared. Okay, so 6 squared 36, and then minus 4 squared 144, 144 plus 36 180, 180. So I have square root of 180. Can I further simplify that? Let me put it in my calculator. Okay, if I further simplify it, I get 6 square root of 5 as r. So that's my value of r. If we go ahead and find r squared is going to be 180 if r is equal to square root of 180. Okay, so right now we can have x minus the value of t, 20 squared, plus y minus the y coordinate of t, not the y coordinate of t, but the y coordinate of g, which is 0. So we have 0 squared being equals to radius squared, which is 180. Okay, so now what we need to do here is just to solve all this and take 180 to the left hand side, and then we're going to have the equation of our circle in the form we are required to have it in. That is going to be x squared, x multiplied by minus 20, that is minus 20. You multiply that by 2, you get minus 40x. Minus 20 multiplied by minus 20, that is plus 400. And then y squared, that is plus y squared. You take 180 to the other side, we have minus 180 being equals to 0. So x squared minus 40x. Let me look at the form so that I don't ruin it. Okay, after x squared, I shall follow with by squared. So x squared plus, what am I doing? Okay, let me look for that again. Where am I? Okay, yeah, so x squared plus y squared minus 40x, and then I need plus dy. Okay, which term has a coefficient of y? There's no term with a coefficient of y, so just to act cheeky, I'm gonna say plus 0y. Okay, and then 400 minus 180 is that plus 220. I think this is plus 220 is equals to 0. I'm supposed to write the equation of the circle in that form. Okay, that is 4.5. The interesting question, really, 4.6. Yeah, this is interesting. Not for the faint-hearted ones. I hope I don't fall under the domain of those with the faint of heart. The smaller circle must be translated k units along the x-axis to touch the larger circle internally. Calculate the possible values of a. So let's make sense of what we mean when we say they touch internally. Okay, so let me do something. Let me trace this circle. Let me use the color red. You're gonna see why I'm doing that. Just stay with me. So I'm gonna trace this circle to the best of my ability. Okay, what I want to do now is to duplicate it. You will see why I'm doing that. Duplicate, and then now let's leave it there. So not there, but yeah. Okay, so when this circle is positioned like that, then the larger circle and the smaller circle are touching internally. That's what we mean. But that is not the only possible scenario. Let me show you the other possible scenario. So I have to duplicate it. When they touch like that, that is another possible scenario where our condition is satisfied. They are touching internally. So this is option 1 and this is option 2. If they're touching like that, we can say that they are touching internally. That's what we mean when we say they touch internally. Okay, so there's 2 ways of doing this. You can do it in an algebra intensive way, or you can just analyze the diagram like I'm about to do right now. Okay, so let me just enlarge this and show you something. Right, so I will erase all this so that I have somewhere to write, and I'll show you what I'm talking about. Okay, I don't want to erase the larger circle. What am I doing? The larger circle must be there. All I want to erase is all these words so that I can have space to write in. Right, so the center of the larger circle, we have 20 and 0, okay? And then the center of the smaller circle, we have 0 and 0. But we have the radius of the smaller circle. The equation for the smaller circle is given by x squared plus y squared is equals to 20. So the radius is square root of 20, okay? Let's look at this point. Let's concentrate on this point. The x-coordinate of that point is minus square root of 20, okay? If the radius of the circle is square root of 20. We need to comprehend that, right? So that is step number 1. We need to be able to realize that. Another thing that we need to realize is, or that we need to figure out, is the coordinate, is the x-coordinate of this point that we are interested in. How can we find the x-coordinate of that point? Let me show you. We know that from this point to the center is 6 square root of 5, or let's just say square root of 180. We know that for sure. But from the center of the Cartesian plane to the center of the circle is 20 units. So if we want to find the x-coordinate at this point that we're interested in, we can just say that, let me enlarge where I have to write now. We can just say that the x-coordinate at that point, let's call it q, right? The value of q is equals to 20 minus square root of 180. We want to move this x-coordinate at that point such that it is equals to 20 minus square root of 180, right? We can have an equation for that which we call q prime. So q prime is equals to minus square root of 20 plus k, right? So when q prime is equals to q, then we can determine the value of k such that the circles touch at this point, okay? So that is 20 minus square root of 180 is equals to minus square root of 20 plus k, okay? So k is equals to 20 minus square root of 180 plus square root of 20, right? So let me just go ahead and put that in my calculator. Let me see what I have. I'm getting k is equals to 20 minus 4 square root of 5, which in decimals is 11.05. So this is one possible value of k. Yeah, this is the same thing. Yeah, one possible value of k. Now let's look at the other case where they touch in at this point. Okay, so let's find the x value at this point. Let's call it z. So z will be equals to the x value at the center, the x value at t, which is 20 plus the radius of the larger circle. So 20 plus square root of 180. Okay, so we want these two circles to touch at the point 20 plus square root of 180. But z prime now will be equals to square root of 20 plus k and not minus square root of 20 plus k. Okay, so if we equate these two, we get square root of 20 plus k is equals to 20 plus square root of 180. So k is equals to 20 plus square root of 180 minus square root of 20. So k is equals to 20 plus square root of 180 minus square root of 20. This is equals to 20 plus 4 square root of 5, of which is 28.94. So these are two possible values of k according to me. Let me know what you think in the comments. I'm quite sure there must be somebody who used the same method I'm using. Just let me know in the comments. Which video do you want me to do next? We have done question 1, 2, 3, 4. Should we just do 5, 6 until 10, or should we? Let me know in the comments. The only questions I'm going to answer is 5.2.1, 5.3.2, and lastly 5.4, because I think they're the most difficult questions. So let's take a look at 5.2.1. We have cos of x to the power 4 plus sine of x to the power 2 multiplied by cos of x to the power 2. Everything divided by 1 plus sine of x. This is said to be equals to 1 minus sine of x. So we're supposed to show that the left-hand side is equals to the right-hand side. If we decide to take the left-hand side, we're going to have, so let me show you something. What I'm realizing first is that on the numerator, I have cos of x and cos of x, which I can take as a common factor, right? In fact, I can take cos of x to the power 2 as a common factor in the numerator. If I do that, I'm going to have cos of x to the power 2, and then I'm going to be left with cos of x to the power 2, because cos of x to the power 2 multiplied by cos of x to the power 2 will give us cos of x, everything to the power 4, right? And then plus sine x squared, okay? We're dividing everything by 1 plus sine of x. So cos of square x and sine of x squared will give us 1. That is identity, okay? So we're going to be left with cos squared x divided by 1 plus sine of x. But we know that cos of squared x plus sine of squared x is equals to 1. So cos of x squared is just 1 minus sine of x squared, okay? Divided by 1 plus sine of x. 1 minus sine of x squared is a difference of 2 squares. So we can expand this and get 1 minus sine of x multiplied by 1 plus sine of x. Everything divided by 1 plus sine of x. So 1 plus sine of x on the denominator will cancel out with 1 plus sine of x on the numerator. We are only left with 1 minus sine of x. So as you can clearly see, the left-hand side is equals to the right-hand side. They are both equals to 1 minus sine of x. That is 5.2.1. Let's take a look at 5.3.2. So in 5.3.2, we are supposed to find the general solution of sine 48 multiplied by cos of x minus cos of 48 multiplied by sine of x being equals to cos of 2x. Obviously, we can narrow this down. We know that we have an identity that can help us with that, right? That will just be equals to sine of 48 minus x. We know that for sure. If you expand the sine of 48 minus x, you get this. So they are equals to each other. Sine of 48 minus x will be equals to cos of 2x. So we're going to have sine of 48 minus x being equals to. We can write cos of 2x as sine 90 minus 2x. So if sine of 48 minus x is equals to sine of 90 minus 2x, then 48 minus x shall be equals to 90 minus 2x. So we're going to have 48 minus x being equals to 90 minus 2x. If we take minus 2x to the left-hand side, we're going to have x. 90 minus 48 is 42. So x is equals to 42 plus k multiplied by 360 because it is a general solution. We are not given a certain interval we are supposed to respect. So that is 5.3.2. The last question that we're going to answer is 5.4. So in 5.4, we're supposed to write sine 3x plus sine x divided by cos 2x plus 1 as a single trigonometric ratio. So with only sine, cos, or tan. That's what we want. Okay? So take a look at this. We have sine of 3x. We don't have any identity that we can use on sine of 3x. So it's better if we break it apart into sine of 2x plus x. If we do that, we're going to have sine of 2x plus x plus sine of x divided by cos of 2x. Let's just leave cos of 2x as it is for this step. Let's focus on the numerator. So we're going to have cos of 2x plus 1. If we expand sine of 2x plus 1, this will give us sine of 2x cos x, okay, plus sine of x cos 2x plus sine of x. We just expanded sine of 2x plus x. Everything divided by cos of 2x. So for this step, let's write cos of 2x as it is again. So we're going to have cos of 2x plus 1. Now we're going to further simplify our numerator. Okay, we have sine of 2x, which we can write it in another form. The same is true with cos 2x, right? Cos 2x is equals to a couple of things. So we can also change cos of 2x. Right, we're going to change sine of 2x to 2 sine, so 2 sine x cos of x. So that is sine of 2x. We are still multiplying with cos x. So we have cos x right here. Plus sine of x. Now we're going to change cos 2x to 2 cos square x minus 1 plus sine of x. Everything divided by. So now we are going to change the denominator. I'm going to show you how. Cos of 2x is also equals to 2 cos of x everything squared minus 1. Okay, and then we have this plus 1 right here. Obviously, minus 1 plus 1, that will give us 0. On the numerator, we're going to have 2 sine of x cos square x plus 2 cos square x sine of x. And then we're going to have sine of x multiplied by minus 1. So that will be minus sine of x plus sine of x. Clearly, minus sine of x plus sine of x will give us 0. So we are dividing by 2 cos of x everything squared. Okay, let's take a look at the numerator. On the numerator, we have 2 sine x cos of x everything squared plus 2 sine x cos of x everything squared. So this is just 4 sine of x cos, let me start with cos instead. This is 4 cos of x everything squared multiplied by sine of x divided by 2 cos of x everything squared. Okay, 4 divided by 2, that is 2 cos of x squared will cancel out with that term on the numerator. So we are only left with 2 sine of x, and this is the expression we are given as a single trigonometric ratio. Write down the period of f. Okay, so let's take a look. We have f of x, which is equals to 2 sine of 2x. So what will be the period of f of x? Let's go ahead and find out. The period is given by 360 divided by b. B being this value that we have right here, the coefficient of x. In our case, b is equals to 2. So we're going to have 360 divided by 2, which is equals to 180 degrees. So this is the period of f. Okay, if you decide to calculate instead. But the question says we must just write it down. Even if you look at your graph, you can see that the graph of f of x, it completes itself between 0 and 180. So the period is 180 degrees. Let's move to 6.2. 6.2, determine the range of g in the interval x, an element of 0 to 180 degrees. G of x is equals to minus cos of x plus 45 degrees. It's very simple for you to make this mistake. You can say that the range of g, we have minus 1 to positive 1. But this is actually not true. This is not the case. Let me show you why. Positive 1 is correct, but minus 1 is not correct. Let's look at g of x. So this is g of x. Okay, if you look at the lowest value, g of x doesn't touch minus 1. So if you write your range in this way, it will be incorrect. You actually have to calculate that value. And as you can see from the sketch, it is clearly not equals to minus 1. So let's go ahead and find that value. So we're going to have g of 0 being equals to minus cos of 0 plus 45. So what is cos of 45? That is 1 divided by square root of 2. So the range of g of x is actually minus 1 divided by square root of 2 up to positive 1. Okay, so this is the actual range of g of x and not minus 1 to positive 1. Yeah, this is because of the restriction we have. We are given an interval we are interested in. Okay, generally it will be minus 1 to positive 1, but here it is a bit different because of the restriction. Just like in question 4 of mathematics paper 1. Let's do 6.3, 6.3.1. So determine the values of x in the interval x, an element of 0 to 180, for which f of x, let's take a look at that. F of x multiplied by g of x is greater than 0. So we want f of x multiplied by g of x to be greater than 0. For this to be true, it's either f of x is positive while g of x is also positive, or the other way around, f of x is negative while g of x is also negative. Yeah, if that is the case, then f of x multiplied by g of x will be greater than 0. So let's go to our graph and find those points. From 0 to 45 degrees, from 0 to 45 degrees, g of x is negative and f of x is positive. So 0 to 45 cannot be part of our solution. But take a look at this. From 45 degrees to 90 degrees. So from 45 to 90 degrees, g of x is positive and f of x is positive. But after 90 degrees, you can see that f of x starts being negative, okay, up until 180 degrees. So we can clearly see that the values of x for which f of x multiplied by g of x is greater than 0 is when x is between 45 degrees and 90 degrees. If you look at your graph, that is easy to see. G of x is positive here. G of x is positive. And the same is true with f of x. F of x is also positive up until x is equals to 90, where f of x starts being negative. Let's do 6.3.2. So that is 6.3.1. 6.3.2, we're looking for the values of x for which f of x is less or equals to, we're looking for the values of x for which f of x plus 1 is less or equals to 0. So we have f of x plus 1 being less or equals to 0. So f of x, if we make it the subject of the formula, should be less or equals to minus 1. Okay, so let's go ahead to a graph and do the analysis. We are given a point A of coordinates 105 degrees for the x value and minus 1 for the y value. Okay, and then as the value of x increases, f of x is negative. And as the values of x increases, f of x is less than minus 1 up until this point. So we're interested on the x value at that point where f of x is no longer less than minus 1. Okay, so we know that our answer should start at x is equals to 105, because when x is equals to 105 degrees, f of x is equals to minus 1. And then we need another x value for which f of x will be equals to minus 1. This x value right here. Our solution will be between those two values. Okay, if you play around with your x values, if you say 105 plus 20 plus 30, you end up figuring out that x, when x is equals to 165 degrees, f of x will be equals to minus 1. So our solution, we need x to be between 105 degrees and 165 degrees. This is our solution. When x is between those two numbers, we can clearly see that f of x is less than minus 1, like we are required to do. Okay, that is 6.3.2. Let's do 6.4. 6.4, another graph P is defined as P of x is equals to minus f of x. D with coordinates k and minus 1 lies on P. Determine the values of k in the interval x is an element of 0 degrees to 180 degrees. So P of x is equals to minus f of x. So P of x is equals to minus, what is f of x? F of x is 2 sine of 2x. So P of x is equals to minus 2 sine of 2x. This is P of x. And then on P of x, we have a point D of coordinates k and minus 1. We're supposed to find the value of k. So we will simply substitute into P of x. If we do that, the y value is minus 1 minus 2 sine of 2k. So if we divide both sides by minus 2, we're going to get sine of 2k being equals to 1 divided by 2. So 2k is equals to sine inverse of 1 divided by 2. So what is sine inverse of 1 divided by 2? That is 30 degrees. Okay, so k should be equals to 15 degrees. 6.4. The last question, 6.5. The graph of h is obtained when g is translated 45 degrees to the left. Translation to the left is plus, right? So when it is translated 45 degrees to the left, that is x plus 45 degrees. Okay, if it was to the right, it would be x minus 45 degrees. Determine the equation of h. Write down your answer in its simplest form. So g of x is equals to minus cos of x plus 45 degrees. If we want to translate it 45 units to the left, then instead of having g of x, we're going to have g of x plus 45. That will shift it 45 units to the left. So minus cos of x plus 45 plus 45. So g of x plus 45 will be equals to minus cos of 90 plus x. They say we must write it down in its simplest form. Can we change cos of 90 plus x into something else? I think we can. Let me know in the comment section how we can further simplify minus cos of 90 plus x. Determine the length of SK in terms of P, Q, and alpha. Let's go to our sketch and identify SK. We have SK right here. We're supposed to find the length in SK of SK in terms of alpha, which is this angle right here, P, which is this side ST, and Q. What is this Q? Let's go ahead and read our question statement and figure it out. So we are told that in the diagram, ST and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta. Angle TSK is equals to alpha. TS is equals to P meters. And the area of triangle STK is Q meters squared. Okay, so we have the area of triangle STK, which is equals to Q. So somehow we have to use the area, because how else can you get Q if you're not using the area? Okay, so let's see if we can use the area of triangle STK to find SK in terms of P, Q, and A. If we go ahead and try that, we're going to have the area of triangle STK being equals to a half. We need two sides and one angle between the two sides. We have ST, right? So multiplied by ST multiplied by SK, sine of the angle in between the two sides, which is alpha. So sine of alpha. So what is the area of triangle STK? We know it to be Q. A half. What is ST? ST is P. SK is what you are interested in, sine of alpha. It should be easy to see that SK will be equals to Q divided by 1 divided by 2 P sine of alpha. This is obviously equals to 2Q divided by P sine of alpha. So this is SK in terms of Q, P, and alpha. 7.1. Let's see if we can do 7.2. So 7.2, we're supposed to show that RS is equals to 2Q tan of beta divided by P sine of alpha. So let's go ahead and take a look at our triangle. This side in dotted lines is parallel as K. Why are we saying that? Beta is the angle of depression. So this angle right here is beta. Okay, we want to find RS in terms of Q, P, alpha, and beta. If you look at triangle RSK, we have a right angled triangle. So we can use tan, cos, and sine. We can use our trig ratio. In our solution, we have tan of beta. Okay, so it makes sense for us to start by trying tan and see if we get to the correct answer. So we're going to have tan theta being equals to the opposite divided by the adjacent. This is in triangle RSK. Okay, so we're going to have tan of beta being equals to the opposite, which is RS. So tan of beta is equals to RS divided by the adjacent. The adjacent is SK. Okay, so we have SK. So if we cross multiply here, we're going to get RS being equals to SK multiplied by tan of beta. But what is SK? We determined the SK in 7.1. SK is equals to 2Q divided by P sine of alpha. So if we replace SK with that, we are going to have 2Q divided by P sine of alpha multiplied by tan of beta. So this is just equals to 2Q tan of beta divided by P sine of alpha. Exactly what we are required to show. That is 7.2. Let's take a look at 7.3. Calculate the size of angle alpha if angle alpha is less than 90 degrees. Okay, We are told that RS is equals to 70 meters, P is 80 meters, Q is 2,500 meters squared, and beta is 42. So let's use the equation in 7.2, because in that equation we have RS being equals to 2Q tan of beta divided by P sine of alpha. In the information we have, we're given the length of RS. We are given Q, the area. We are given the angle beta, and P, right? P is said to be equals to 80 meters, and we are looking for alpha. So if we use this equation, we are only going to have one unknown variable, which is what we're interested in. Okay. So if we go ahead and cross multiply and divide, making sin alpha the subject of the formula, we're gonna have sine of alpha being equals to 2Q tan of beta divided by P multiplied by RS. Okay, so we're gonna have alpha being equals to sin arc of, so let's go ahead and substitute. We have 2 multiplied by Q. Q is 2,500 multiplied by tan of beta. Beta is 42, okay? And then we're dividing everything by P multiplied by RS. P is said to be equals to 80 meters, and RS is equals to 70 meters. So it is just a matter of putting that in your calculator. And when I do that, I'm getting 53.51 degrees. So that is the size of angle alpha if alpha is less than 90 degrees. In the diagram, O is the center of the circle, and ABCD is a cyclic quadrilateral. OB and OD are drawn. If O1 is equals to 4x plus 100 and C is equals to x plus 34, calculate, given reasons, the size of x. So I'm given C, it is equals to x plus 34. I have O1, okay? But C plus A should give me 180, as ABCD is a cyclic quadrilateral. So if I can find A in terms of x, then I can say A plus C is equals to 180. But I can do that. I can find A in terms of x. I know fully well that O1 should be equals to 2 multiplied by A. Angle at the center, twice at the circumference, okay? So O1 is 4x plus 100, and it is equals to 2 multiplied by A. If we divide both sides by 2, we're going to get A being equals to 2x plus 50. So this is A, okay? So what am I proposing? I'm proposing that A plus C should give me 180 degrees, okay? The opposite angles of a cyclic quad are supplementary. So in place of A, I have 2x plus 50. In place of C, I have x plus 34 being equals to 180 degrees. So 2x plus x, that is 3x. 50 plus 34, that is 84. This is equals to 180. So 3x is equals to 180 minus 84. I think it should be 96. But I'm not going to take any chances. I'm going to put it in my calculator and see what I get. Yeah, it is 96. And then 96 divided by 3, that is 32. So I'm getting 32 is equals to, x is equals to 32 degrees. That is 8.2. Let's see if we can answer 8.3. So 8.3, right. In the diagram, O is the center of the larger circle. Okay, we have O as the center of the larger circle. OB is the diameter of the smaller circle. Chord AB of the larger circle intersects the smaller circle at M and B. Okay, so I'm told that AB is a diameter. As soon as I hear AB is a diameter, I know that M is 90, right? A diameter subtends 90 as a circumference. Let's hear the stories. We want to find 8.3.1, write down the size of angle OMB. Like I've said, angle OMB is equals to 90 degrees. That is because it is subtended by a diameter, okay, at the circumference of a circle. So it should be 90 degrees. The question that follows, 8.3.2, if AB is equals to square root of 300. So this entire AB is square root of 300. And OM is 5 units. So OM is 5 units. Calculate, given reasons, the length of OB. Okay, we want to find OB. It seems like we can use theorem of Pythagoras here because we have an angle of 90 degrees. But can we find the length of MB? Because what we are looking for now is the length of MB. If we have the length of MB, then we can find OB using theorem of Pythagoras. Let me show you how we can find the length of MB. MB is equals to AB divided by 2. That is because if OMB is indeed 90, then that means OM bisects AB. Theorem 1. Okay, so we know that MB is equals to square root of 300 divided by 2. If I go ahead and use theorem of Pythagoras, it seems quite fishy. I don't know why it is 4 marks because it is pretty much straight forward. Okay, so if I go ahead and use theorem of Pythagoras, I'm going to have OB squared being equals to MB squared plus OM squared. So OB squared will be equals to MB. So MB square root of 300 divided by 2 squared plus OM. OM is 5 units. So I have 5 squared, okay? So OB squared will be equals to, let me put that in my calculator. So square root of 300 divided by 2 squared plus 5 squared, that is 100. So OB is equals to 10, okay? If we take square roots on both sides, which will get OB is equals to 10. So yeah, there we go. That is 8.3.2. A, B, C, D is a parallelogram with AB being equals to 14 units. AD is produced to E such that AD is to DE is equals to 4 is to 3. So AD is to DE is 4 is to 3. It is not necessarily 4 and it is not necessarily 3. But when we divide them, we will get 4 divided by 3. Okay? And then EB intersects DC in F, and then EB is equals to 21 units. Right, stories. Let's look at the first question, 9.1. Calculate with the reasons the length of FB. So we want to find the length of FB. We know that EB is equals to 21, okay? So EB divided by FB should be equals to EA divided by DA. Why am I saying that? DF is parallel AB. So the two sides are divided proportionally. Okay. So what is EB? EB is 21, like we have in the information. FB is what we're interested in. This will be equals to EA. EA will be 7x divided by DA, which is 4x. We can see x and x cancels out. If we cross multiply, we get 7FB being equals to 21 multiplied by 4. So we have 7FB being equals to 84. If we divide both sides by 7, we get FB is equals to 12 units. So there we go. We have the length of FB. Let's get to 9.2 and see if we can prove, given reasons, that
triangle EDF is similar to triangle EAB. Okay, the way these triangles are named, the angles they follow a certain order. Let me show you what I'm talking about. We have triangle EDF and triangle EAB. Okay, angle E on the two triangles should be equals to each other. Okay, so let's take a look at triangle EDF and triangle EAB. We can see that angle E is a common angle. Okay, so we can say that E is equals to E. This is a common angle of the two triangles. Let's go to the angle that follows. Angle D in triangle EDF. So this angle D in triangle EDF should be equals to angle A in triangle EAB. Okay, so we have angle A being equals to angle D. Which reason can we use? We can see that the line DF is parallel the line AB. So angle A is corresponding angle D. Okay, so we're gonna say that angle D is equals to angle A. This is corresponding angles. So we have corresponding angles because DF is parallel AB. If we've proved that two angles are equals to each other in two triangles, then the third angles are also going to be equals to each other because of the sum of angles of the triangle. Okay, so this angle F should be equals to angle B. Okay, so we have F being equals to B. We can use third angle of triangle, or we can also use corresponding angles. So now we can go ahead and conclude and say that triangle EDF is similar to triangle EAD. Angle, angle, angle. That is 9.2. 9.3. Calculate with reasons the length of FC. So let me just go ahead and erase this. I want to find the length of FC. Okay, FC has nothing to do with our triangle, with our two triangles, right? But DF has something to do with our triangles. DF. If we can find DF, then we're going to have FC because AB should be equals to DC if ABCD is a parallelogram. So how can we find DF? Let me show you what we're going to do. We know that this is 14. We know that we have 3x and 4x. We want to find DF. Okay, so on the smaller triangle, ED divided by DF should be equals to EA divided by AB in the bigger triangle. Okay, what reason can we give? We can say that triangle EDF is similar to triangle EAB and not EAD. Okay, so there we go. ED is 3x. DF is what we are interested in. This is equals to EA, which is 7x. AB is 14. Okay, x and x can cancel out. If we cross multiply, we have 14 multiplied by 3, which is 42. So 7DF is equals to 42. 42 divided by 7 is 6. So DF is equals to 6. Okay, but we know that DC is equals to AB, which is equals to 14 because ABCD is a parallelogram. So FC will be equals to 14 minus 6, which is equals to 8. 14 minus 6 is 8. So FC is 8 units. And just like that, we have the length of FC. There's no values in this question. We're just writing angles in terms of one another. Let me show you what I'm talking about. So the first question, 10.1, we are supposed to prove, given reasons, that S3 is equals to S4
S4. Okay, but before we can attempt answering this question, let's go through the question statement so that we can extract our keywords that are going to help us in answering the question. Okay, so in the diagram, PQRS is a cyclic quad. So now I know that I have a cyclic quad. So let me write that down as it will help me in answering the questions. Okay, PQ is equals to PR. That is also important. PQ is equals to PR. Yeah, equal chords subtend equal angles at the circumference of the circle. Right. The tangents to the circle through P and R meet Q as produced at A. Okay, we have some tangents, AR and AP. So let's go ahead and write that. We have tangent. We know that we have the tan chord theorem. So it is important for us to know the tangent, okay? What else do we have apart from the tangent? Okay, I think that's what we have up to so far. I cannot think about anything else. Yeah, I cannot extract anything else from the question statement. So let's go ahead and give it a try and see what happens. Okay, I had a lot of people saying that they couldn't even answer one question from question 10. I wonder why that is the case, but I hope I'm going to be able to get at least one correct. Let's see. So S3 is equals to S4. Let's look at our first keyword. Our first keyword is cyclic quad. So let's see if we can make sense of that. Okay, we have S3 right here. So if SRQP is a cyclic quad, then S3 should be equals to angle Q. Right, so let me just write that down as part of my solution. It is something I'm realizing, so I need to write it down. So 10.1, I have S3 being equals to Q. As S3, it is an exterior angle of a cyclic quad, okay? What else am I realizing? Let me move to the following keyword. The following keyword is that PQ is equals to PR. Let's see what the consequence of that is going to be. PQ is equals to PR. So PQ subtends angle R3 and PR subtends angle Q. So what does that tell us? Okay, that will tell us that Q is equals to R3. That is because PQ is equals to PR. Okay, but if S3 is equals to Q and Q is equals to S3, and Q is equals to R3, I mean, then S3 is equals to R3 because they are both equals to Q. Okay, I think we can say that. Okay, let's pay our attention to the chords before we can move on to any other idea. Okay, so we say that R3 is subtended by PQ. But if you pay close attention, you should be able to see that PQ is also subtending S4. Okay, so what are we saying? We're saying that S4 is equals to R3 because they are both subtended by our chord PQ. Okay, I think the right reason is that they are in the same arc. That is the right reason. So take a look at this. S4 is equals to R3. S3 is equals to R3. So S3 should be equals to S4 as they are both equals to R3. Okay, if x is equals to 2 and y is equals to 2, then x is equals to y because they are both equals to 2. Okay, so that is 10.1. Let's move forward and do 10.2. Let's hear the stories. So 10.2, let's prove that SMRC is a cyclic quad. Okay, let me go ahead and highlight SMRC. So I have S, M, R, C. Let's make sense of this question, okay? If SMRC is a cyclic quad, then this angle C1 should be equals to the angle M1, okay? Exterior is equals to interior opposite, right? And then S1, so this angle S1 should be equals to angle R1 plus angle R2, okay? I'm realizing something. I'm realizing that S4 is equals to S1. And in the question above, we've talked about S4. So why not try prove that S1 is equals to R1 plus R2? Because we can just carry on from what we've been doing from 10.1. We don't have to necessarily start anything new, okay? So I'm going to start by saying S1 is equals to S4, vertical opposite, okay? Let me check if they are indeed vertically opposite. So I have this line and I have this line, okay? S1 and S4 are indeed vertically opposite, okay? And then let's not forget, in the question above, we said that S3 is equals to S4. And now we are saying that S1 is equals to S4. So what does that mean? It means that S1 is equals to S3 as they are both equals to S4. Okay? Right, now we can see what is happening here. Let's not forget, let me remind you of something. We said that S3, this angle right here, is equals to Q1 plus Q2. That is because SRQP is a cyclic quad, okay? So S3 is equals to angle Q, exterior angle of a cyclic quad. But I want to show you something interesting. Look at R1 plus R2. R1 plus R2 should be equals to angle Q because of the tan chord theorem, okay? So R1 plus R2 are equals to angle Q because of the tan chord theorem. You will see where I'm going with this. You will see when I connect the dots at the end. R1 plus R2 is equals to Q. Can you see now? S3 is equals to R1 plus R2 as they are both equals to Q. Okay, but what we are required to prove is that S1 is equals to R1 plus R2. But we have proved that S1 is equals to S3. So now we're going to say that S1 is equals to R1 plus R2. This is because both of them are equals to S3. Like I said at the start of the question, we are writing angles in terms of each other. There's no value in this question. Okay, so let me just erase for the sake of clarity. We have proved that S1 is equals to R1 plus R2. So SCRM is indeed a cyclic quad because, so what are we saying? We're saying that therefore SMRC is a cyclic quad because S1 is equals to R1 plus R2, okay? The exterior angle is equals to opposite interior. That is 10.2, okay? And the interesting question, 10.3, right? If you thought 10.2 is difficult, then what about 10.3? Let's take a look at 10.3. So in 10.3, we are told that RP is the tangent to the cycle passing through P, S, and A at P, okay? So RP is the tangent of the cycle passing PSA. So we have some cycle right here. And we are supposed to prove that RP is a tangent, right? So if RP is a tangent, let me show you something. This is a chord on the cycle, right? Let me use a different color. this is a chord on the circle. If RP is a tangent, then P2 should be equal to the angle subtended by that chord, which is A2. So if we can prove that P2 is equal to A2, then we've proved that RP is a tangent to the circle passing through P, S, and A at P. Okay, so let's see how we can do that. Let me erase all this for the sake of clarity and zoom in. Right. Okay, so let me see. Let's take a look at M3. Okay, M3 is an exterior angle of triangle MAP, right? MAP. So we can say that M3 is equals to A2 plus P1 plus P2. This angle here, A2, and P1 plus T2 are equals to M3, right? An exterior angle of a triangle is equals to the sum of opposite interior. Let's not forget that. So we have M3 being equals to A2 plus P1 plus P2. Okay, we can also use M3 again. We can say that M3, okay, let me see. M3 is equals to, let's see, S4 plus P2. Let me erase again for the sake of clarity. So we can say that M3, this angle right here, is equals to S4 plus P2. So what are we saying? We're saying that M3 is equals to S4 plus P2, so P2 plus S4. Okay, for the same reason, exterior angle of a triangle. It's just that now we are concentrating on a different angle. Okay, right. Let's equate these two equations. I want you to realize something. If we equate these two, we're gonna have A2 plus P1 plus P2 being equals to P2 plus S4. Okay, so we want to prove that A2 is equals to P2. If we can find a way to show that P1 plus P2 are equals to S4, then A2 will be equals to P2. So that's what we essentially want to prove, right? So let's go ahead and try doing that. We already know that S4 is equals to S1, right? They are vertically opposite. But if you look at S1 from what we have proved in 10.2 should be equals to R1 plus R2, right? Exterior angle of a cyclic quad is equals to interior opposite. So S1 is equals to R1 plus R2. Exterior angle of a cyclic quad, so on and so on. Because of the tan chord theorem, R1, let's take a look at R1. R1 is equals to P2 because of the tan chord theorem, right? And then still, because of the tan chord theorem, P1 is equals to R2. So instead of saying S1 is equals to R1 plus R2, we can say that S1 is equals to P1 plus P2, because R1 plus R2 is just equals to P1 plus P2 using the tan chord theorem. So we have S1 being equals to P1 plus P2. But S1 is S4. So S4 is equals to P1 plus P2. This is because of the tan chord theorem. Okay, so let's come back to this equation that you're interested in. We can replace S4 with P1 plus P2 because we have showed that S1 is equals to R1 plus R2, which is equals to P1 plus P2, and S4 is equals to S1, which is equals to P1 plus P2. Okay, so we're going to have A2 plus P1 plus P2 being equals to P2 plus, in place of S4, we have plus 1 plus P2. So take a look at this. P1 plus P2, P1 plus P2. So A2 is equals to P2 because A2 plus P1 plus P2 is equals to P2 plus P1 plus P2. So A2 should be equals to P2 because of that. And this is the most difficult Euclidean geometry question I've ever solved.